Hello, this is the question 10 of homework 8, and we want to show that if the normal process is white sans stationary, then it is strict sans stationary. So when we get a normal process, it can be read like this, so which is f x1, x2, and xn, and this is t1, t2, tn. So when we write the cross of them, which is c, t1, t2, and the last is tn, it is equals to e, which is in a matrix form. This is x t1 minus e x t1 and x t2 minus e x t2, and the last one is x tn minus e x tn, and multiplied by the x t1 minus e x t1 and so on, and the last one is x tn minus e x tn. So because the normal process is white sans stationary, which means the ex is a constant. So all of them ext1, ext2, extn are all of the same constant, which is like eta. So we can write this in this form, so which is x t1 minus eta x t2 minus eta x tn minus eta, and this is x t1 minus eta x tn minus eta. So when we multiply them together, it is e x t1 square minus eta square, and this is x t1 x t2 minus eta square. This is only the this and this, because when we get when we get like this, x t1 minus eta and x t2 minus eta, and multiply them together. So this part is this, and this part minus this, and this part minus this is minus 2 eta square, and the last one is plus n square. So the last one we get is this. And also we know that the rate of them is xt1, xt3 minus eta square, and so on. And this is xt2, xt1 minus eta square, and so on. And the last one is xtn square minus eta square. So because we know that when we get this ext multiply xt, it is r t1 t2. This is also t1, and this is r t1 t2 minus eta square, and so on. So this is also r t2 t1 minus eta square, and so on. And last one is r tn minus eta square. And so in this form, we know that when this is t1 t1, it is the tau of t1 minus t1 is 0. So this is equal to r 0 minus eta square. This is r t1 minus t2 minus eta square. and so on. And this is also r t1 minus t2 minus theta squared. And the last one is r also t1 minus tn minus tn is 0, so this is also 0. So in this form, this is 0, t1 minus t2, t1 minus t3, and so on. So this can be changed from like this is the c of t1 minus t2, t2 minus t3, and so on. And this is t minus 1 minus tn. So because this is well-sun stationary, we can change like this Tc of T1, T2, and Tn in this form T1 minus T2, T2 minus T3, and Tn minus 1 minus Tn. So we know that f x1, x2, xn, and of T1, T2, Tn, it is equals to f x1, x2, xn, and T1 minus T2, T2 minus T3, and so on. So if we want to know if it is strict sun stationary, we should know that if the f x1, x2, xn, t1 plus epsilon and t2 plus epsilon and so on, and tn plus epsilon, if it is equals to this. So we can change this form also in this form, which is f x1, x2, xn, and this is t1 plus epsilon minus t2 plus epsilon, and so on. So because this is equals to t1 minus t2, and other parts are also the same, can be changed to like t2 minus t3, and so on. So because this T1 plus epsilon and T2 plus epsilon can be changed to this form T1 minus T2, T2 minus T3. And we know that T1 minus T2, T2 minus T3 is also the form of which is the fx to xn and T1 to Tn. So this is equals to this part. So now we know that because it is the normal process is white sun stationary and then it is strict sun stationary.